Hello everybody, welcome to my YouTube channel. Before getting started, I would like to go over the previous lesson that what I have done. As you know, I give you 25 theorems in triangles, and I have tried to present this topic to you in the best way. I hope you will have a better understanding at the end of the videos. Just watch it over and over again. Actually, I feel very happy to reach you through technology and share my knowledge and experience with you. I think sometimes learning through experiences outweigh learning through books. In this video, I am planning to show you how should our approach be when we are confronted with geometry questions. So let's get to it. On the first question, triangle ABC given. DE is parallel BC and O is the intersection point of the bisectors of interior angles. BD is 6 cm, EC is 4 cm, and we will find the length of DE. So if DE is parallel BC and O is the intersection point of bisectors, so we can say angle B and angle C will be angle bisectors. So let me draw it first. From B to O and C to O. O is the intersection point, and we will have here is two angle bisectors. DE is parallel BC, so the measure of angle OBC and BOD alternate interior, so they must be equal. So triangle BDO is isosceles. It means that the length of BD is equal to DO. And BD is given 6 cm, so the length of DO will be 6 as well. And here is another alternate interior angle we have. The measure of angle BCO and COE, alternate interior angles. EC is 4 cm, and automatically OA is also 4 cm. We found actually the length of DE. The length of DE is equal to sum of DO and OE, which happens to be 6 plus 4 is 10 cm. So give a look at the second question. There are 4 triangles. Triangle ABC, ADB, BEC, and ACF is given. And also the lengths of the sides are given, such as A, B, C, 7, 7, 5, 10, 8, and 9. We have to find minimum value of A plus B plus C. So when we solve this problem, actually we are going to apply the triangle inequality theorem. You can remember this theorem from the previous lesson. So what was it? One side is between difference and sum of others. So let me start first in triangle BCE. And here is A is between absolute value 10 minus 7 and 10 plus 7. So it's going to be 3 is less than A is less than 17. It is the first. And the second, let me take triangle ACF. So B is between absolute value 9 minus 8 and 9 plus 8, which is going to be 1 is less than B is less than 17. And the last one is triangle ABD. So absolute value 7 minus 5 is less than, C is less than 7 plus 5. So C is between 2 and 12. So we have to find the minimum value ABC. So it means that for each inequality, we have to take smallest value of A, B, and C. If A is between 3 and 17, for A is smallest value 4, for B is 2, and for C is 3. all you need to do is take the sum of 4, 2, and 3, which is going to be 9 units. And here is triangle BAC is a right triangle. The measure of angle B is 75. The measure of angle C is 15 degrees. And the length of AB is given 6 centimeter. We have to find the length of AC. Okay. So the measure of angle B is greater than the measure of angle C. So here I can get one isosceles triangle. How can we do this? I will separate 75 such as 15 and 60 degrees. So I have to draw line to side AC, and this line intersect side AC at point D. It's 15 degrees, so it should be 60 degrees. And the sum of interior angles of a triangle is 180, so it must be here is 30. Or the sum of two interior angles will give us one exterior remote angle. And so triangle ABD is special triangle. This 30 degrees, 60 degrees, and 90 degrees. So AB is the shorter leg, AD is longer leg, and BD is hypotenuse. So we know that hypotenuse is twice as long as shorter leg, so BD will be 12. And the longer leg is root of 3 times as long as shorter, so it must be 6 root of 3. So BDC is an isosceles. Automatically, the length of BD is equal to DC. It's also 12 centimeter. So the length of AC is equal to the length of AD plus the length of DC is 6 root of 3 plus 12 centimeter. Okay, question 4 says side EF is parallel to side AC. AK is equal to KD, so K is the midpoint of line segment AD. BD is 2 times greater than DC, and AE is 3 centimeter. We are going to find the length of EB. And here is, if EF is parallel to side AC, also KF is parallel to AC. So we say that C and F, A and K, they are corresponding angles, and D is common angle between triangle DFK and DCA. So we say triangle DFK is similar triangle DCA. By using triangle proportional theorem, AK over KD is equal to CF over FD. AK is equal to KD, so they cancel each other. So we say that CF over FD is equal to 1, which means CF is equal to FD as well. So let's say if FC is Y, DF must be also Y. So we can go another similar triangles. And here is triangle BFE and BCA is also similar triangles. So we are going to apply the triangle proportional theorem. AE over EB is equal to CF over FB. But before solve this section, BD is equal to 2 times DC, and DC here is 2y, so the length of BD will be 2 times 2y is 4y. Okay, so we can look at our proportion now. AE is 3, EB is, we don't know, let's say x, is equal to CF is y, and FB will be 4y plus y is 5y. Cancels each other out, so 3 over x is equal to 1 over 5. By using cross production, 3 times 5 is 15, x times 1 is x. So the length of x is 15 centimeter. For the question 5, AC, BD, and DC given 22, 8, and 6 centimeter respectively. And we are going to find the length of AE. Let me represent it by x. So if A is x, EC will be 22 minus x. So to solve it, maybe we will go back on time. Remember our previous lesson, what we have done. I give you Seva, Stewart, and Mendel's theorem. Actually, in this question, I'm going to apply the Mendel's because line BE intersect triangle ADC at 2 different points F and E. Automatically, I write BD over BC times CE over EA times AF over FD is equal to 1. AF and FD, they are equal, so we can simplify directly. So we will have just BD over BC times CE over EA is equal to 1. So all you need to do is write in the place of BD is 8, for BC is 14, for CE is 22 minus x, for EA is just x. So it's going to be 8 over 8 plus 6, 14 times CE is 22 minus x over x is equal to 1. We can simplify it by 2. It's 4 and it is 17. 4 times 22 minus x is equal to 7 times x times 1 is going to be 7x. 4 times 22 by using distributive property, 88 minus 4x is equal to 7x, and I will bring it over. 88 is equal to 7x plus 4x. So 88 is 11x divided by 11 both sides, x, which happens to be 8 centimeter. Question 6 says, K is the intersection point of AP, BR, and CS, and the length of BP is x centimeter, PC is 6 centimeter, CR 8 centimeter, AR, Y, AS 4, and SB is 6 centimeter. So we have to find the ratio of x and y. By Seva theorem, I will write BP over PC times CR over RA times AS over SB is equal to 1. If we substitute the given values into the equality, we get x over 6 times 8 over y times 4 over 6 is equal to 1. So from here we will get for x over y is 9 over 8. The question 7 is with you. If, as in the figure, AH is perpendicular side BC and AB is 10 cm, BD 6 and DC 4 cm, we will find the length of AC. Let AC is x, AD is K, DH is P, BH is M, and HC is N. If we apply the Pythagorean theorem in triangle DBH and DHC, we will have m squared plus p squared is equal to 36. And n squared plus p squared is equal to 4 squared, which means 16. When we take difference between these two expressions, we will have m squared minus n squared is equal to 20. It is the first equation that we found. M squared minus n squared is equal to 20. It is the first one. And now let me apply the same theorem in triangle ABH and AHC. So I will write m squared plus k plus p squared is equal to 10 squared is 100, and n squared plus k plus p squared is equal to x squared, and I will take a difference between first and the second expression. So I will have m squared minus n squared is equal to 100 minus x squared as the second expression. If we substitute the value found in 1 into the equality 2, I will find 20 is equal to 100 minus x squared, because m squared minus n squared is 20. So take negative x squared to the left and 20 to the right side. 100 minus 20. So x squared is equal to 80. That is, when we take root of both sides, it is 16 times 5. We have to find here one perfect square, which means 4/5 centimeter. What is it? It is the length of AC. In the following question 8, BAC is a right triangle and AG is perpendicular GC. AG is given 6 centimeter and we have to find the length of AC. First, I will like to start by extending line AG to the side BC. And when we extend the line AG, the line intersects BC at point D. And according to median theorem, AG is twice as long as GD, which means GD is 6/2 is 3. And we also know that the length of the median to the hypotenuse of a right triangle is equal to half the length of the hypotenuse. So we conclude that AD is equal to BD is equal to DC. As 6 plus 3 is 9 centimeter. Additionally, in triangle GDC, we are going to apply the Pythagorean theorem. So GD squared plus GC squared will give us the length of DC squared. So GD is 3 squared is 9. GC squared, we don't know, is equal to DC is 9 squared is 81. So from here, for GC squared, we are going to get 72. When we take root of both sides, we will have plus minus 6/2. But for the length, we cannot, that the lengths cannot be never negative. So we will have to take the positive one. Use the positive. We found GC. GC is 6/2. And after that, it follows in triangle AGC. AG squared plus GC square is equal to AC square. AG is 6, so the square root of 6 will be 36 plus GC square we found just 6 root of 2 square will be 72 is equal to AC square. 108 is AC square. When we take root of both sides, for AC we will have 6 root of 3 centimeter. So in the figure, the length of MK is 6 centimeter, NT 5 centimeter, NK 4 centimeter, and TP is 3 centimeter. And also the area of a triangle M and P is given 80 centimeter. And we have to find the area of K and T. So it's time to put our knowledge and experience into practice. Again, we have to go back on time. We have to remember what we have done on the previous lesson. Remember that I give you a sine theorem. Yes, when we find the area of triangles, we can apply the sine theorem. So to find area of K and T, I will write 1 over 2 times product of side NK and NT as 4 and 5 times sine n degrees. So it will be 4 and 2 cancels each other out. 2 times 5 is 10 times sine n degrees. I found the area of K and T. What is it? 10 times sine n. So what is the area of triangle M and P? Again, we will use here the sine theorem. 1 over 2 times the length of M times NP as 10 times 8 times sine n degrees is equal to 1 and 5. We can simplify by 2. 5 times 8 is 40 times sine n degrees. The area of triangle M and P is given 80 centimeter square. So from here we will get for sine n degrees is 2. So to find area of K and T, all we need to do is substitute in the place of sine n is 2. So it will be 10 times 2, which means 20 centimeter square. For the question 10, the lengths of the sides are given 3, 6, 3, 4, 2, and 6. And the area of triangle M and P is 504 units square. So we are looking for area of triangle KTS. And to solve this problem, I will go theorem 25 on the previous lesson. So according to theorem 25, we can find a ratio of triangle KST and MP and N. How can we find this? Let me write first NT times PS times MK plus TP times MS times KN over the length of NP, PM, and MN, which is going to be 7 times 8 times 9. So the area of triangle KTS over the area of triangle MNP is given 504 units square is equal to, is 3 times 3 is 9 times 2, 18. And 144, which is 162 over 504. So the area of triangle KTS is 162 units square. So we found here the shaded area. It's going to be 162 units square. 11 is the last question of the video, and here in this figure, three lines are parallel to each other, such as AD, EF, and BC. In this case, we have one theorem. We say 1 over EF is equal to 1 over AD plus 1 over BC. So 1 over x is equal to 1 over 6 plus 1 over 3. When we equalize denominators by 1 and 2, 1 over x is equal to 1 plus 2 over 6, which means 3 over 6. When we simplify by 3, we will have is 1 over 2. 1 over x is equal to 1 over 2, which means x is 2. We got x. What is it? 2. And after that, EF is parallel BC, so we will have two similar triangles such as AEF and ABC. So by using triangle proportional theorem, AE over EF and AB over BC. Let me write this. AE over EF is equal to AB over BC. AE is Y, EF is 2, AB is Y plus 2 over BC is 3. And cross production, 3 times Y is 3Y is equal to 2 times Y plus 2. So 3Y is 2Y plus 4. Bring it over. 3Y minus 2Y is Y is equal to 4. X is 2. X is 2. Y is 4. So what is the sum of X and Y? 2 plus 4 is 6. Okay, I would like to end up my video here, and good luck in all that comes your way in the future. See you on the next video. Bye.